developers, one full-stack Netflix clone. Francesco builds the backend, I build the frontend. By the end of this video, you'll see exactly how to build a full-stack app like Netflix end-to-end from the backend to the frontend. Hey everyone, I'm Shruti Kapoor, and on this channel, I break down difficult concepts of React, web development, JavaScript to make it easy for you to get started and succeed in web development.
Welcome everyone, I'm super excited because today we will build a Netflix backend clone using Rust.
And in this video, we're building 4 core features of a Netflix app: trending movies, search functionality, playing a trailer, and video streaming. I'll handle everything you see and interact with, and Francesco is going to build the backend in Rust. On the front end, I'll be creating a Netflix-style UI, a trending now component that has a slide-in carousel, a search bar that shows results as you type, a video player for watching trailers, which also has streaming built in, and all of this will be using React and TanStack Start. Remember, the goal here is not to replicate Netflix and build a production-level Netflix app, but to show you how a full-stack app is built from front-end to back-end and show you how front-end and back-end communicate. So if you're ready, let's get started.
In this project, we will use the TMDB API. Here, I created an API key, so I will leave the link below, by the way. And we will use, of course, Rust and Axum, which is a backend framework for Rust. Now let's start to set up our project. The name of our project is Netflix_backend, but you can name it however you want. Let's add some dependencies. For example, of course, Axum, the framework here, and let's say that I will add Axum 0.7. Most of the tutorials now are using this version of Axum, so 0.7.9. Do you see here this bulb? This is very useful because it's suggesting me to update to a newer version. In our case, this is mandatory because the syntax changed a bit between Axum 0.7 and 0.8. So be sure to use the latest version of Axum. It might be a bit different, but use a version newer than 0.7.9, okay? Let's add some other dependencies. I will be quick here, but I will explain. .env is to read environment variables, for example, from a file. Request, let's pretend I don't know what is that. You can click here on the left, and this will redirect us directly to the documentation. Request create provides a convenient higher-level HTTP client. I really love this feature of clicking here and just go to the documentation. Third is used for serialization, and so is served_JSON. Tokyo, what is Tokyo? Tokyo is a runtime for writing reliable network apps using Rust and without compromising speed. Event-driven, non-blocking. Okay, we'll not go into details, but it's the most famous runtime for writing a synchronous application using Rust. We also need this tower HTTP. We will use this crate to stream and serve the video. Okay? And by the way, when I want to add not all the features, like for example, I do like this here, but just some of them. For example, here we'll add the course and FS for files. So we will use tower HTTP also for course issues, cross origin. If we type this here, features, we can type here, I think it was course and FS. Of course, with quotes like this. Okay? For now, all of them are gray because JetBrains is complaining that I'm not using them, but I still have to create the project, so please give us some time. The next step is to create a .env file because, as I mentioned, we will use an existing API, the TMDB API. We will fetch them on with our backend, and then we will serve them to our front end. So let's create a .env file with alt-ints. At least from Windows, you can create a .env file like this. And in this file, do you want to add this to Git? No. It should also be in the git ignore. Let's do this before I forget. So .env here, and here we will have a key like this. So tmdb_API_key, and here my key. Of course, we need to replace this with your TMDB API key. Now, let's actually create this backend application. I will copy-paste some code, but we'll explain line by line, no worries. We will need 4 files: models.rs, state.rs, handlers.rs, and finally a main.rs file. So let's go one by one. Let's create the first file called models.rs. Okay, we import the third first for serialization and deserialization because we need to create a server, and we need 5 structs. Structs in Rust are used to create basically objects. The first one is for the movie, and we have basically all strings and one number here for the vote average, ID, title, name, overview, and of course we will see this in action soon. We will use this struct. Another one is for the TMDB response, so when we fetch some list of movies from the TMDB API, we'll have a vector, a dynamic array of these movies. And also we need the current number of the page and the total number of pages of this TMDB response. Another struct we need is for the single video, and we have ID, key, site, type, and name here, all strings, and again a vector of these videos, in this case just with an ID and this dynamic array of these videos. This will be used, of course, in the HTTP responses and to serve this for the front end. The last struct we need is the page query that just returns a number, basically. And we're done with the models.rs file. Now let's create another file, alt-ins for Windows. This file will be called state.rs. This file will be very short. We are just creating a super simple struct with the TMDB API key, the one which is in the .m file, and this client request. That's it. This is basically for the application state. We will use this soon in the main.rs file. But I think the most important file for this application is actually the handlers.rs file. We need to write 3 endpoints here. Let's import what we need here: Axum, the create models here, and the state. I see here I'm missing one model. So we missed one more, which of course is for the search query. This is specific for this one. And of course I've done this intentionally so you can see the cool feature by JetBrains. So this error was 100% intentional. You can have here this query string and the page number here. Thank you so much, Rust Rover. So the handlers file will have a super basic endpoint that just returns a string. I always like to have something like this when I create an application, so I will use this just to test that the server is running. So here I'm not even doing a request to TMDB. This is usually the first endpoint that is at the root of the web server, so without any path. Now let's see the handlers one by one. I copy-pasted, but let me explain line by line. We have this public asynchronous function to get the trending movies, and we have in input the state and some query parameters. And the return type of this function, you see this arrow, is a TMDB response, the structure that we defined a few minutes ago. Let's go back to handlers, and here we define a page. We set this URL, so we make a request to TMDB with, of course, the API key, and then we get this response, and then we write this here. You might notice that here we don't have the return keyword, because in Rust usually when we have a simple flow, we don't need to type return JSON res semicolon. We just type what we want to return without the semicolon. This is not a typo. Let's see another handler. It's very similar, to be honest. This is for the search content. We have the same parameters in input and the same return type. We have the same page, but you see the request is different here to the movie db.org, and we pass the state, but also some parameters, because maybe we want to make some search based on something here. And we get the response, which is still of type tmdb response. And the last endpoint is get movie videos. This is to get all the videos related to a specific movie. We will provide in input the ID, the number of a movie. We will use a matrix, if I'm not wrong, and we'll get all the videos related to, for example, the movie matrix. But you see here, the answer is a video response, which is a quite different struct, because this is a list, because this is a vector of videos. And we are done now with the handlers. You might be surprised because we didn't write anything to actually serve the video, but hold on, stay with me for 10 more minutes and you will see some Rust magic. We need just one more file, the main.rs. This is definitely not enough to have a web server in Rust. It's also complaining now that we don't have the main function. Okay, let's import some stuff. Axum, of course, .env to handle the environment variable, standard library for the environment variable again, Tokyo with the TCP listener, this is will be used for the server, and tower HTTP. Let's also import all the modules. In this case, they are simple files like this. You see, we import handlers, models, and state. We need to use the state defined in the state.rs file here, and also we need to define the handlers from the module. You see, everything has to be explicit, and Rust is not scanning our files, scanning our folders. Okay, we have in these handlers some public functions, and this is why in the main we can actually see them, but we need to be explicit about what we need. Let's make the compiler happy, and let's create a function. This will be an asynchronous function main, because we will add as an attribute the magic Tokyo main. So this is why we can write this async fn main. Now here we need to check the .env file. This is basically what the .env package is doing here. And also here, I think we do something very useful, which is we manage what will happen, for example, if we don't have a .env file, if our API key is set wrong. So at least with this expect we will get an error in the logs, for example, if we are missing this .env file. If you clone this project without adding your own .env file, you will probably get this error. We need to define the state of the application here. So let's state equal upstate using the TMDB API key and the client. And I love this, in a single line, we get rid of all the course issues. Thank you so much, course package. To avoid me some headaches. Now something that if you are familiar with Express you will like, let app.route. So we are defining all the routes based on the handler, and then we have this very magic line, nest service /stream serve dir, and this will be used to actually serve the video. We will have a video locally on this server, and also we will deploy this application later, but this is basically enough for now. We might improve it, but for now this is way more than enough for this small project. .layer course, so we solve all the course issues, thank you, and then with this state. We are not done yet. Again, something very similar to Express. We set this listener, we bind this to a port. I'm using 0000 because this will be served with Docker later. So we have a println, and then finally we serve the server. We are done with all the code of our application. If you have any question, just feel free to drop it below and I'll be happy to answer. Before we test this locally, I want to also create a directory called assets. And inside this, I want to add my file. I have a video here. Feel free to add your own video. If you want to follow along with the tutorial, you can call this file video.mp4, so you don't have to change the code. And this has to go in the assets folder. Check the structure here, otherwise you might get some errors. You see here the nested service is using something inside the assets, and we will fetch this video. And of course, in this case, we'll not handle the errors. We will just want to test this exactly video.mp4 file. You can use a different name here, but in that case, when we'll make a test later, remember to change this video name with the name of your own video. Before we keep going, I want to try it out. And I don't want to use a PowerShell, but I want to use Git Bash by default. So I click here, Terminal, and here I have a drop down, so by default I will use Git Bash. Let's try again, Control backtick. Now I have Git Bash here, cargo run. This is to run our server locally. All the code will be available on GitHub, no worries. And this is of course a mistake that I made on purpose, because the TMDB API key must be set in .env not present. Why? Because I put that in the wrong folder. It should not be in the src folder, but at the root level. Here, refactor. Amazing. Let's try again, cargo run, allow. The compiler is complaining because you are not using this one. I think you can remove that line if this warning annoys you, but everything should work. Localhost, bam, Netflix backend is online. I also want to try quickly just one more endpoint, but I don't want to spoiler all of them. But you can see that here we have the response in JSON format served on the browser. Here, Man vs. Baby, Stranger Things, Zootopia 2, Spartacus, Avatar. I think I want to watch this movie. Now I might try all the endpoints locally, but no, I want to Dockerize this project because later I want to deploy this application, so I want to try it in a similar environment also on my machine. And of course, to do this, you need to install Docker. I will need a link below. Now, Dockerizing this application should be quick, and I will be quick because this is not a Docker focus tutorial. We need 3 files. .dockerignore, be sure to be at the root level, this Netflix backend folder for me, .dockerignore file, then a file called dockerfile capital D. You see also we have the Docker logo here. So this means that I didn't make a typo, and then compose.yml. So we should have these 3 files. Let's populate these 3 files. The first one is the .dockerignore, like this. Target, we don't want the target folder, that's basically the build, the Git repo. We will get our .env file in a different point. I will share this later. The Docker file, I will be quick here, but I still want to explain. We are basically using a multi-stage build. We start from this Rust image from Docker Hub, and we call this builder, this stage. We create a folder called app, and basically we step into that directory. We install some build dependencies. This might work even without this line, but it's nice to have. We copy all the source code inside this folder inside the image, and then we run cargo build -- release. So we are building the project not locally, but directly when we build an image. And I think that there is an advantage in doing this. Then we have another stage, runtime. We start from Debian distribution. We install runtime dependencies. We copy the binary from builder is the result of this part of this stage. We copy the assets folder, because this is not part of the Rust application, it's an external folder, and then we expose the port 8080, and then we basically execute this app program, not app.exe or something else, because we are in a Linux distribution. The super cool part of the Rust is that since we are building this in a Linux distribution, we will have a Linux program and not a Windows like I would have here. I will probably have this here on my machine. Let's try. You see here I have a .exe file, but here I will have a file called app, and we're just using Linux. This is a super cool part of Rust. This might be enough, but I want to use a compose file even for a single service. This is the file services. By the way, this is not a typo, but this is my name on Docker Hub. We want to build using a Docker file in the same folder here. We want to give a proper name, otherwise it would use the directory structure. I don't want this, I want exactly this name. We want to expose this port 8080, and then here, finally, we are using the .emb file. And also we have this environment port. Maybe we want to set an environment port later. For now, this is fine. I want to make this in 2 steps. First, I want to do docker compose build, and then if that works, I will do docker compose up, which is the command to actually run our service. And this might take a while. Now let's run our application, docker compose up. Bam, server listening, and we have the same port. Let's try localhost. Netflix backend is online, but this time we are running this in a Docker container, and this makes a big difference because now it will be easier to deploy. Now, to test this application, we can use this in different ways. I will show you different ways to do this. We can have, for example, a set of curls. I have them all here. And we might, run all of them, this curl, for example, here on the terminal. But since we are in a very powerful IDE, let's use it. For example, we can type shift and we can click here on HTTP client. I am in this rest-api.http. If I copy paste the curl, I have this with this magic green button here. Let's do this for all of them. Let's try it out. For example, let's click here, run localhost 8080. I'm running, by the way, a Docker container. Ctrl-Shift-5. I can split my terminal here. Docker ps-a. You can see the container here. Let's click here. Okay, and we have the response that is inside our IDE. We can also do this from the browser, of course, but you see here we have, it's remembering, for example, this, with some additional information. I can try also this one to make a search based on the query matrix. These are all the videos related to a specific movie. We provide an ID for matrix is 603. Of course, this is a backend, so we need to know the ID. And the last one is this one. Let's try it out because here we are actually streaming a video. If I click here, 200. Okay, but I don't see the video here, of course. Why? Because the video is served directly in the browser. So let's copy paste this. This is a very important test to do. Let's try it out. Let's copy paste this URL here. Let's try.
Workdev has launched on Product Hunt and his 8-bit CN project is amazing.
And it works. I muted it, otherwise you can't hear me. This is amazing because we also have controls here. So super cool, served directly from this machine. This is not a URL. It's a file in the folder of our project inside the Docker image. Super cool. We are not done yet with the cool features because I want to show you the famous debugging feature of all the JetBrains IDEs. For example, here I can go here on the handlers. Let's pick this one. I can put a couple of breakpoints here, these red dots. I need to stop the server, and then I can run this in debug mode. You see this button here, debug run, also F5. I will click the button here. Let's see what happens. Nothing, because of course I have to run the request. I think it was this one, search query matrix. And you see here, and this is super powerful, I can see the status of my application, including the value of all these variables here. This is a super powerful way to debug our application. In this case, it's easy, but it's just to showcase the potential. If I click here on this button, resume program, you see we go on the next breakpoint. This is a super cool feature. I've been using this intensively. Let's stop everything here because we are not done yet. Why? Because to let Shruti to use my API, my backend, I need to actually deploy this somewhere. The course issue is already solved, but I need to deploy this. There are different ways to do this. I decided to use DigitalOcean. I think this is the easiest way. This project is not focused on deployment. Let me know if you want to make something specific about this. Basically, here you can create a droplet. They are called like this. And then inside the droplet with Docker, we can just download, pull the image from Docker Hub. This is my Docker Hub account. You see this Francesco XX Netflix backend? And I wrote the compose.yml file. You see here, I define this name. And if I write here Docker compose push, it will push this to our Docker Hub account. In this case, I didn't do it, but you can try this command if you have a Docker Hub account. This server has a public IP, and this is exactly what we need. Before we do the final test, I want to do something which I think is very cool. I want to check how much memory we are using with this Rust application. Rust is famous for being efficient. Let's see if this is real. I am here in the droplet, so basically on the server. If I type Docker images, I see my image here. And if I type Docker stats, you can actually see how much memory we are using. So we are in idle, but this server is using 6 megabytes of RAM. And this is not even optimized. We are not focused on the optimization. We are now focused on the deployment phase. But I might actually get even a better number here. This really makes me proud. This makes my Rust heart really, really proud. I probably can publish 100 applications on this server, in idle, of course, but very impressive numbers. Now let's try it out. And to do this, I will just use the browser. You see here I'm using a public IP, and we have a Netflix backend is online, but this is public. Let's try also the other endpoints, for example API trending, and we see this. This is exactly what Shruti will use with her front-end application. Let's try this query metrics. All the queries related to metrics. Just two more. These are all the videos related to the movie 603, which is metrics, of course, internally. This is just an API. Of course, we need some mapping. And the last one. If this does work, we are done. HTTP, the public IP, stream/video.mp4. Let's try it out. It works. I also have controls here. And this is a video on the remote server. So we made it. This is, of course, a proof of concept, but this is very powerful. We did in a single video a working project, which I think is super cool. We are almost done, but I want to show you this Juni, a coding agent. I didn't use it for this application, but for example, I can use this for some upcoming videos, and I want to use it here for this simple task. Write, update a readme.md file for this project. This project doesn't have a readme.md file, I'm guilty. Let's see what's the final result. Again, all the code will be available on GitHub. No worries, it created the readme. It's also updating the task progress. Super cool. It's done. Let's check it out. We have the readme for my project. Super cool. I should check it out, but this looks like a very cool readme. It's something. Okay, it has to be tested, but you will find this readme in the project. Let me know if you can follow along or if this readme is wrong, is not giving the right information. We are done with this demo, and this was for the backend. Now, Shruti, over to you, because I really don't like CSS.
For this video, we're going to use TanStack Start as our framework of choice. In order to get you started, I've created this starter template which you can use. All you gotta do is check out this code and you'll be good to go. Once you check out this app, you will have a basic TanStack Start app up and running. Now in this video, I'm not going to go into the details of TanStack Start, but if you're new to TanStack Start, I have a free cheat sheet for you which will help you get started with TanStack Start and remember the important functions of TanStack Start. It will be linked in the description right below, and it's completely free for you to check out. With the code already set up, we're actually good to go. So let's take a look at the project structure. The heart of TanStack Start lies in TanStack Router, which is set up by the root file. This is where TanStack Router, DevTools, and any header information is set. And the router file is where we create the TanStack Router. What's important for us is the index file, which is where we're going to be adding our components. So when you open localhost 3000, this page is powered by the index file. Now, I've already added the hero component in here. This is just a static component that shows a text and email field and honestly doesn't really do anything. The trending now component is where we are going to integrate with Francesco's Backend API. So let's get started. First step I'm going to do is to actually run my backend server. Now I've got the backend running, and the next thing I'm going to do is verify if I can access API/trending. Perfect. I can access API/trending. At this point, take a note of the shape of this data. Got a JSON with a field of page, results, and the result has an ID, name, overview, poster path, and backdrop path, vote average, release date, media type. So you can imagine that for our trending now component, we would need the ID, the title, maybe the overview, but definitely the poster path, and maybe the backdrop path. But one thing to remember is that this data is within the results object, and also it is a paginated list of items, which is great. So let's go ahead and create this component so that we first fetch from this API call, and then we can render these results nicely on the page. So the first step is to actually call this API so we can get this data. Now, how do you call an API? If you are doing a client-side app, you would probably do something like a use effect or use a library like TanStack Query. But instead of fetching this giant data on the client side, we could actually do a little bit better and fetch data on the server side. Now, since we are using TanStack Start, we can use create server function to fetch on the server. This function is written down in the cheat sheet, so if you don't know TanStack Start, the cheat sheet will be helpful at this point. So what do we have to do? In the index file, remember that we have a file root here. This is the index page. Now the first thing I need to do is create a server function. Create server function comes from React Start, and I could provide a method here if this was a post request, but in my case, this is a GET request, so I'm going to keep it as is, and then provide a handler. Now this is where I'm actually going to be fetching my data. I'm going to be creating my handler here. If it was a post request, then I could provide a method in addition to handler. But since this is the GET request, which is the default, I don't have to provide that. All right, so let's create a handler. Handler is going to be an async function. And within this handler, this is where I will fetch the API. And I definitely want to wrap this within a try catch. So instead of fetching from TMDB, we're going to fetch it from our local host. And of course, when the API gets deployed, we want to update this, but we've got localhost at 8080 and our URL is API/trending. And now instead of returning just the results, I'm going to return data.results, since we remembered it was part of result. Now, how do we call create server functions? We can call them within the route loader itself, which is perfect for data fetching, or we could use within the component itself using use server function hook. For us, we're going to call it within our loader. So let's do that. Because TanStack Start is built on top of TanStack Router, we get that functionality out of the box. So in addition to component, we can actually add a loader here. And in the loader, we're going to call async get movies and then return movies. And to get that data from the router into the component, all we got to do is call route.useLoaderData.movies. And then we just supply the movies to the trending now component, and it should have access to all of the movies that are trending now. Let's go ahead and fix trending now component so it actually takes movies, and we're going to render just the name of these movies on the page, or just let GitHub Copilot fix this for me. So if I load my page, I have a small typo here. I need to add this. There we go. Oh, nice. That's actually looking pretty nice. This is not the scroll functionality that Netflix has, but we can see that our trending now component is actually displaying movies. Let's go ahead and add the nice scrolling feature of Netflix. First, I'm going to refactor this app a little bit to create subcomponents called movies list and movie card, so that these are actually reusable components. Okay, I've created a movie list component in which I've passed movies, and I'm just mapping through movies to create a movie card. In the movie card component, I've actually added a Shadcn card component, and I'm providing the image. The movie card component is actually pretty simple. I've got a card component which I've added from Shadcn component, and I'm just adding the image here. And my trending now component is a lot simpler now, because now it adds movie list component, which in turn adds the movie card component. So now it makes a lot more sense. It's a lot more cleaner and maintainable. Now let's go ahead and style trending now component. As of now, it looks like this, but we can make it look prettier. So if you notice in our movie list component, we've got an unordered list. This is where I'm going to add an X scroll. Let's go ahead and add some styles to this component so that the scroll bar is actually hidden. Scroll bar height, space X4. Nice. They look kind of nice. F4 maybe too much. Okay. Now let's also fix this card component so that it takes up the whole space. To do this, we're just going to add class name to our image, add width full, height full, and make it a cover. Okay, so I've added some height, some width to the card component, added some rounded borders, and added some rounded borders to images as well. So now if I hover on it, it looks nice, but I'm noticing that it actually cuts off. So let's add overflow by visible to the list. And now it is looking nice. Okay, that is our trending now component. There's a little bit of extra padding here, which is bothering me. So I'm going to go ahead and fix this off camera, and we'll be back to implement the search functionality. Let's implement the search functionality now. To add search functionality, we're going to add a search icon in here. And for now, let's also remove the language selector and authentication. We don't need that right now. I'm going to add the search icon from Lucid React. And in order to add the search icon, I just need to npm add Lucid React and include the search icon, which there is a huge variety of icons for. So let's go ahead and find it here. I'm going to include this one. So in order to add that, I just need to get Lucid React, which I already have, and add it to my component. Let's take a minute to understand how this is going to work. So the way I want this to work is similar to the search bar in here. So as you see, when nothing is clicked or when nothing is typed, the search bar is collapsed. But as you expand, it opens up. And then as I start typing, it'll start searching for that item. You'll also notice that if I type really fast, like, it takes a second to actually load the data, which means it's not firing request as soon as I'm typing. That means that there is some form of debounce happening there. So we're going to keep those things in mind and implement that. Another thing to note that is when I type something, the URL also changes. So this is a searchable URL. So let's see how we're going to do that. Now, because we are using TanStack Start, we're in luck because this kind of searching is provided to us out of the box through TanStack Router. This is called search params. The way this works is that we're going to create a new endpoint /search, and then whatever is passed in after that gets passed in through an object down to us. Let's take this example and implement it. One cool thing is that you can also validate the search params, which is super helpful for us as well. Let's go ahead and do this. Now, the first step is to create a new route here called search.tsx. I'm going to rename this route component to be search component. In order to read this, I have a few different options. I can read it directly in the loader and validate the search, or I can use route.useSearch to get the parameters out. Let's test this and get movie equals route.useSearch, not params. And now I'm just going to log the movie that's passed in. So now if I go to /search movie equals Christmas, I see Hello Christmas. Perfect. That works. Okay, the next step is to actually add a search icon here. So in order to do that, let's create a component here called search. In fact, let's call it searchbar.tsx. So one thing you'll notice is that if I go to search, you'll notice that everything that I have on the page goes away. And that is because I'm not inheriting anything from index.tsx. I've done all this work in here, but now in search.tsx, it's not part of it. So one way to do that in TanStack Router is to actually create a common component or a common layout and then import that within the root layout. For our case, since on the video player page, we do not want to have a header, I'm going to skip that part. But remember, if you want to reuse components across multiple pages, you can actually create a new layout and put that as part of your root component. But for our case, since we are only adding it on one page, let's just go ahead and add the header component here. So now on this search page, I've added the header component. Let's go ahead and fix our header component so we actually have a search bar in here and none of this stuff. The first thing, I need import search from Lucid React. I'm going to import that in here. And I'm also going to use the router's link component to actually do the job of searching. We'll see that in a second. Okay, adding text white, and that looks nice. Okay, now let's do the important part where when somebody types a movie in the bar here, like movie equals Christmas, we actually use our API to do a search. And then we're also going to debounce that request, so we're not calling it multiple times. So let's do the first part where when we hit search/movie equals Christmas, we are actually making a request. So basically, the way we want to do this with TanStack Start and TanStack Router is that when you hit that endpoint /search, this is when the router loader kicks in. So what we want to do is that once we have this query in, we want to fire our TanStack Router to actually use this value, the search params value, and fire a request. In order to fire a request, we want to do that on the server, and we can do that with create server function. We already did this for trending APIs. So let's go ahead and add this create server function. So in TanStack Start, you can have your server function within the same file. So I'm going to create a function here called search movies API equals create server function, handler, async movie, try, blah, 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 response. Okay, probably half of this code needs to be replaced. Localhost 8080 is where my environment is running, I think. Let's just give it a quick test. Missing field query equals Christmas. Sweet. And this is where my results are. Perfect. This is what I need to do. And then I just need to wait for the JSON and get results back. My results are also in the array, so this looks fine to me. But remember, with TanStack Start, we also get type safety out of the box. So we can actually add a validator here, input validator, that checks whatever data is coming in against a schema. So we can actually provide a query schema here. And this is super helpful because this way we can be sure that our movie query is one of type string and two has at least something. So that is my create server function. And now in the loader, I just need to call this create server function that I created, and it gives a list of movies. And I can just send this movies back from the loader into the component. And now instead of using route.useSearch, I could use route.useLoader data and get movies out here. Before we move forward, I've also added a loader dependency function here, which makes sure that if search gets updated, we fetch new value. And what we do here is we set movie parameter to be the search parameter dot whatever query we pass in, which is dot movie, and then we pass that down to loader function. So now instead of checking for just search params in the loader itself, we first make sure that we added the dependency so that we can refetch if a search has updated. Now you see on the right side that we've got some Christmas movies coming in. Of course, they are not styled, so we can style them in 1 second. But now if we click on this search field, we actually don't have an input. So let's go ahead and add the search. In this search bar, I'm doing something very simple. I've added an input component. The search bar is actually pretty simple. If the search bar is clicked, then I want to show an input field, which is right here, which means if we should show search that the item is clicked on, then we should show an input field. If it is clicked away, then we should show it away. This is a pretty straightforward search bar, but if you want to see the code is going to be linked in the description as well in the GitHub repo. So go ahead and check that out. But let's go ahead and implement this search query change, which is something that happens when you type in this field. So as we type on this field, we get the data out in value event.target.value, and we just want to set our search value, which is the value of this input field, to be that value. So it gets set. And now as we type, we also want to search. To do that, we just got to implement this debounce function. And then once the debounce value is greater than 500 is when we actually navigate using the useNavigate function from React Router. And it is as simple as just calling navigate. Now remember, if we didn't have navigate in use in a debouncer, we would actually be adding navigate while we are searching. So add in set search value, which as you can imagine would be a lot of keystrokes. So now if you look for Christmas, I see Christmas movies. And if we clear, then we don't see anything. If I actually browse to this page, search movie equals Christmas, I also see Christmas movies. Nice. And now with a little bit of style, my Christmas movies look nice. Cool. And now here's the homework for you. We've got the trailers endpoint where if you pass in the movie ID, it actually gives you a list of trailers on YouTube. Your job is to implement the video player component. So when you click on it, it should start playing the trailer. By the way, if you haven't watched this movie is amazing. Watch it. This is actually not that difficult to do. We've taken a look at how to fetch data on the server using create server function. You can utilize that to fetch the API for fetching a trailer. For adding this video component, which is the only tricky part in this, you need to use the HTML video component, and you're actually going to pass in a source here. And this is the same source that you're going to get from here. So you actually get an ID, and then you just need to pass in a YouTube URL here. So what you could do is embed the YouTube component itself here, or add a source with this ID for YouTube. So there's two ways to implement this. But if you get stuck, don't worry, all of the code is gonna be in the GitHub repo, and you can check that out if you get stuck. So good luck. One thing to remember is that your video player component should not have a header at the top. The styling is optional. You can keep it as simple or you can make it as pretty as you want. If you get stuck, remember, the code is in GitHub. Good luck. So I hope that video was helpful for you in understanding how to build a full stack application from the backend to the front end, how to consume an API, how to build an API, how to talk to that API from the front end, and how to build a Netflix-like app. If this video is helpful for you, put down in the comments what you want to see next and hit that subscribe button. Thank you so much for watching. I'll see you next. And say thank you to Francesco for filming the backend part of this.